Hi, in this lesson we are going to look at support vector machines. Scholastic Video Book Series Part 1 Linear Support Vector Machines LSVM. scholastictutors.webs.com. Support vector machine SVM algorithms are used in classification. Classification can be viewed as the task of separating classes in feature space. For example, there are two features here, x1 and x2. So there are two classes here, the blue class and the red class. So what our task here is to find out a boundary that can separate these two classes effectively. We might think that this can be one of the possible boundaries, but you might argue it is not the best. You might think this may be the best, this may be the best, or this one. So what support vector machines does is actually you can define an optimum boundary to classify these two classes. So what we are going to learn here is how are we going to get this optimum boundary. Often support vector machines will use 3 or 4 support vectors to classify to obtain the boundary. So let's see 3 support vectors. We'll assume that we are going to use 3 support vectors, namely S1, S2 and S3. The idea of support vectors is to get 3 vectors which are closer to this space in between these two classes. This is actually a area that can belongs to both the classes depending on how you define the boundary. Either of the classes, it can belongs to either of the classes depending on your boundary. So we select S1 as one of our support vectors, S2 as the other one, which from both are from the class blue class, and the third one from the red class. So we utilize these 3 support vectors and try to come up with an optimum boundary to classify these two classes. So our first support vector S1 has coordinates 2, 1, feature x1, 2, feature x2, 1. It can be sometimes maybe the weight of a certain fruit, maybe the length x1, the feature x1. So it depends on how you define. Maybe this can be another feature. Normally it can be some other feature of the fruit. Depending on how you define, it can be length, but normally length is not negative. If it is weight, it can be positive, but the length we can define with respect to some value. If it is less than some value negative, it is more than some value positive. So it's a feature. X2 is a feature, x1 is a feature. So it depends on the type of object that you want to classify. So S1 has the feature x1 equal to 2, feature x2 equal to 1. Similarly, S2, 2 minus 1, S3, 4, 0. Now we use these 3 support vectors to get the class boundary. Here we are doing a simple modification. Basically what we do is we are going to augment the vectors by adding an extra 1 as a bias input, and for clarity we differentiate this with an overtitle. That is, this is our normal support vectors that we saw just now, and we add extra number here. 2, 1 will become 2, 1, 1. That is the bias input, always is 1 here. 2 minus 1, 1, 4, 0, 1 is extra 1 is added, and then the vector support vector S1 will become S1 title, S2 become S2 title, S3 become S3 title, Only difference is that we have an extra 1 as the bias input. So let's see why we use that one. So we are going to use these three modified support vectors in our calculations. Okay, so this is what we have in hand, and now we are going to the theory of support vectors. Here we need to find the parameters alpha 1, alpha 2 and alpha 3 based on three linear equations. So this is the first linear equation. Please note, it's very simple. S1 is based on the S1 tidal, S1 tidal, S1 tidal, and it is alpha 1 S1 tidal plus alpha 2 S2 tidal plus alpha 3 S3 tidal, and it's equal to -1. We assume that blue class is the negative class. Similarly, we take S2, 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 rest is same, and we equate it to -1 because this is the negative class. And when you take S3, please note that we equate it to +1, and the rest is similar. S3, 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 alpha 1 S1 tidal, alpha 2 S2 tidal plus alpha 3 S3 tidal times or multiplication. Let's see how we multiply that one. Basically these are vectors, so let's substitute the vectors into these equations, these three equations. So these are the three equations that we have, and now we're going to substitute them in these three equations. Very simple. What we are going to do here is use our modified support vectors. So the support vectors you can select according to your needs. Here we have selected 3 of them. It can be 4, 5. Let's see how we select more vectors later, and substitute them in this equation. 2 1 1 2 1 1 support vector S1 tidal 2 1 1 S1 times S1 tidal 2 1 1 plus alpha 2 times S2 tidal 2 minus 1 1 times S1 tidal 2 1 1 plus alpha 3 times S3 tidal times S1 tidal equal to -1 because this came from the negative class. Similarly, the other vector S2 vector belongs to negative class. We get the equation by substituting in this equation. This is S2, 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 2 minus 1 1, S1 2 1 1, S2 2 minus 1 1, S3 4 0 1. Okay, same procedure for the next feature vector, support vector, which is equal to +1, and this is S3 tidal. Okay, now we have 3 simultaneous equations with alpha 1, alpha 2, alpha 3 unknown. Okay, so these are the substituted values now. Now we simplify this one. So let's simplify the first equation. We get here, let's see how are we going to simplify this one. 2 times 2, 4 plus 1 times 1 plus 1 times 1. 4 plus 1 plus 1, 6. 6 alpha 1 plus 4 times alpha 2. How you got 4? 2 times 2 is 4, minus 1 times is 1 minus 1, plus 1, 0. 2 times 2, 4 alpha 2 plus 4 times 2, 8 plus 1, 9. Middle one is 0. 9 alpha 3 equal to -1. Similarly, you can try to simplify the second equation and the third equation. So you get 3 simultaneous equations. Let's, for clarity, let's take the last one. Alpha 3 times 16 plus 1, 17 alpha 3. So just simplify these equations to get this one. Then your task is to simplify these 3 linear equations. You can use MATLAB or some simple program, or can use simple calculation by substituting alpha 1 into this one and alpha into this one. By reducing the unknown parameters, you can find out alpha 1, alpha 2 and alpha 3. So after simplification, we managed to find out that alpha 1 equal to alpha 2 equal to -3.25 and alpha 3 equal to 3.5 for this particular problem. Now we are going to get the boundary using these three parameters. How are we going to do this? This is what we found: alpha 1, alpha 2, alpha 3. We selected S1, had S1 tidal, S2 tidal, and S3 tidal. And from the theory again, we have a definition for the hyperplane. Basically, we call it the boundary between the two classes as the hyperplane that discriminates the positive class from the negative class. So this is a very important equation where W is the equation for the hyperplane. W tidal is equal to sigma of alpha I times Si tidal. Basically, you multiply all the alphas with the corresponding support vector and add them up to I. So there are three vectors in this case. I become 3. So substituting the values, we get W tidal equal to alpha 1 times S1 2 1 1 plus alpha 2 times S2 hat 2 minus 1 1 plus alpha 3 times S3 hat 4 0 1. Very simple. Alpha 1 minus 3.25, alpha 2 minus 3.25, alpha 3 3.5. So you multiply this with this, this with this, this with this, you get this one. So how do you simplify this one? Basically, minus 3.25 times 2 plus minus 3.25 times 2 plus 3.5 times 4 will become equal to 1. The next line, minus 3.25 times 1 plus minus 3.25 times minus 1 plus 3.5 times 0 will become 0. Last one, this times this, this plus this times this plus this one times this equal to negative 3. Okay, now we have obtained the equation for the hyperplane that may discriminate the two classes. Let's see how, whether it's correct or not. Okay, so this is how, this is the equation, that is the equation for the hyperplane 1 0 negative 3. How do you interpret this one? So please note that we augmented the class or the vector by using extra 1 here. So basically this is called the bias. Now even for this hyperplane, this will become the bias for this hyperplane. 1 0 is the hyperplane and the minus 3 is the bias. So therefore we can separate it out. Basically this is W after modification, and we take out W from W tidal, and the offset is the minus 3. So basically it is an equation y equal to wx plus b with w equal to 1 0 and offset b equal to negative 3. So how are we going to plot this one? Basically w equal to 1 0 is a vertical line. It has a gradient of 90 degrees, 1 0, and offset 3. Basically b minus 3 b equal to minus 3 actually goes through plus 3 here. This is the offset. So to clarify the point here, 1 0, if you get a number like 0 1, so your plane will be a horizontal line. If you get a b offset equal to plus 2, it will go through minus 2 here. So basically the offset will be the value when you add the value here 3 to this offset, you get 0, and 1 0 is a vertical line. So we can actually, this is our answer. Basically this is our hyperplane. So this is the expected decision boundary for the linear support vector machines. And this one, the term linear is used because the hyperplane that you require here is a linear one. So for example, some cases these two classes will not be so separable. You need to find out another function to change it to a different domain. Here it is separate, linearly separable, but say you have 4 vectors here, 4 elements here, and the other 4 elements or other number of elements around there in the other class. So you can't simplify because this is in a different, there is no linear boundary. So you need to find out a function that can transform it into a different domain, so which we do it in a subsequent lessons later on. For linear support vector machines, the boundary is clear. This is just straight line. Okay, so we come to a simple program code here, an example using MATLAB or any other programming language. We can simply derive this one, simply obtain these answers. Either you can do using a paper and pencil, or you can write a simple code. For in this case, this is the 3 support vector version. It can be more support vectors, so you take a simple example here. Support vector 0 minus 1 1 0 minus 1, the bias is 1. Support vector 2 0 1 1. Support vector 3 2 0 1. This is the vector 2 0 1. So we have 3 support vectors, and we assume they are in 2 different classes: blue class, negative class, red class, positive class. So if you look at here, so this is what we saw in the equations previously, the summation equation with alpha, the values of the S1 times S2, S1 times S1 plus the summations of basically there's a space here. This is not multiplication. In this program we have this is the first element, second element, third element, fourth, fifth, sixth, seventh, eighth, ninth. There are 9 elements here. There's a space in between. So basically this is the matrix A. We can calculate the matrix A, and then this is y is A equal A times x equal to y. So x's are the alphas, A times x equal to y. So y's are the definition of the classes. A negative class, first one belongs to negative class, second one belongs to negative class, third one belongs to positive class. Negative 1, negative 1, negative plus 1, positive 1. And if you divide y by A, right hand side by the matrix A, you should get the alphas x. So p, q, r are the values of the alpha. So x1, x2, x3 are the elements of this matrix. Will give you the values of the alpha 1, alpha 2, alpha 3 in this particular case, p, q, r. And then substitute in the weight equation, p times or alpha 1 times s1 plus alpha 2 times s2 plus alpha 3 times s3 will give you the weight or the boundary of the hyperplane. So in this particular case, we should get 1 0 negative 1. If you run this code, you should get 1 0 negative 1. Negative 1 to mean that x1 has offset 1. So it should go through this point here, because the bias is negative 1. So as we saw earlier, it should be positive 1, and then the line is vertical, because 1 0 1 0 is actually our the hyperplane equation of the hyperplane. It is a vertical line. If it's 0 1, it will be a horizontal line. Okay, that's the code example 1. Code example 2, very similar. We have 4 different vectors here, 4 different support vectors we can select here. This is called 4 support vector version. So these are the equation, these are the coordinates of the support vectors. You can verify them, and this is a summation. Please note that there's a space in between the sum value. So these are 16 element matrix here, and then when you divide y by A, you will end up with alpha 1, alpha 2, alpha 3, alpha 4, and go to the W equation and simplify. You get equation for W title 1 0 negative 2. This is a vertical line again passing through x1 equal to 2. So x1 equal to 2 is the offset, because this is minus 2 here, offset is 2, and this is our support, the classification boundary or the hyperplanes separating these two classes. And this is an example with 5 support vectors. So the equation, the coordinate of the support vectors are given here. 3 belongs to the blue class. Oh, please note that whenever you have a class, so please, I'm going back again. Please note that these 2 belongs to the blue class, minus 1 minus 1. These 2 belongs to the red class, plus 1 plus 1. So you need to change the equation y here according to the the points that you select here. You could have selected these 2 into a different class. So depending on how you arrange them, you need to tell S1 belongs to -1 class, S2 belongs to -1 class. If you had selected S2 to be this one, so then you should change this to +1 because that one belongs to red class. So it's up to you to select Y depending on the selection that you made for S1 to S4. Similarly, S1 to S5, here first 3 belongs to negative class, the blue class, 1 0 2 0 3 0, and this one 2 2 3 2. So this belongs to the positive class. So simplify, you get the hyperplane equation for hyperplane W title equal to 0 1 negative 1, 0 1 negative 1. So again, negative 1 means it is crossing yeah, in this particular case, this negative 1, because this line is a horizontal line, so it is actually a horizontal line passing through x2 equal to 1. So the bias is 1, and it is it's a horizontal line, because this is, if it is 1 0, it's a vertical line. It's 0 1, it's a horizontal line, and it passes through. You can see it's nicely separates the two classes in here. So you can try these examples with different numbers here. You can put this in different places and see how this class boundary calculates from this equation, for a simple program. So it's kind of a interesting thing to see how the class boundary or the hyperplane comes out of the solution. And the last slide is to check with the simple answer that you got. You got the hyperplane. Now our task is to classify unknown vector. So say you are doing support vector machine classification. You have these 5 support vectors, which are the original ones you have selected, and now we are given a new vector and ask you to classify it to which class that belongs to. So now it's the task here. So we have this the plane for equation for the hyperplane, which is 0 1 0 1 minus. I took the last one that we used, which is with the 5 support vectors. We got this one as the modified hyperplane. 0 1 is the equation of the hyperplane, -1 is the bias, which passes through x2 equal to 1. This is exactly what we got in the last slide. And now we are given a point 4 2. 4 is the value of x1 and 2 is the value of x2. So we have these two values, and then actually visually we can see it belongs to the class negative class, the red class, but it's a positive class, the red class. So but mathematically how we do it, so just substitute w times x. Just this is the hyperplane equation for hyperplane times x. X is the vector here, 4 2, and 0 times 4 is 0, 1 times 2 is 2, 0 0 plus 2 is 2, which is greater than 1. This is the boundary, offset 1, but this offset is greater than 2, therefore this belongs to the positive class. If it is less than 1, less than the bias, it belongs to negative class. So here the first point belongs to the positive class, and the second point we took 2 negative 2 2 minus 2. Obviously it is here, but mathematically how do you do it? You substitute here 0 1 times 2 minus 2, you get 0 times 2 is 0 plus 1 times minus 2 less than 1. So you can say that this point belongs to the blue class. So we can do it for any point in this boundary, in this space. You take the point and substitute in this equation, see whether that is greater than or equal to, greater than or less than 1. So depending on, if it's greater than 1 belongs to red class, less than 1 belongs to the blue class. Okay, that's how we can simplify support vector machines into very simple terms without any complex arguments. We can say that support vector machines are simple algorithms that uses some of the representing vectors which are close to the boundary to get a optimum separating boundary or optimum hyperplane for a linear classifiable problem. But if the problem is non-linear, that means if you can't see a clear linear boundary, then we need to go for non-linear support vector machines, which will be covered in a subsequent lesson.